Okay. Hello students. So today we'll discuss something new, that is composition of functions. So far we have discussed about functions. I hope you are very clear about what you mean by function, and we had discussed two types of function, that is one function and onto function, and one more which is many one function. What happens if a function is not one, that is many one function. So if a function is both one and onto, then it is a bijective function. I hope you're clear with everything. Now we will discuss about composition of functions. So what do you mean by composition? Composition means, I hope you know the meaning of the word composition, which means combining. When you have two or more things, if you do composite, so that the product is nothing but the composite of that three things. So here we'll combine two or more functions. So before going into the actual definition, what do you mean by composition of functions? I'll just give you a real life scenario where you can apply this composition of functions. Okay, suppose a student, okay, a student named Amit. Amit is a student. Okay, he wants his marks. Okay, he wants to know his marks in the mathematics subject and the final examination. So we have a computer. So we'll have a computer. But in order to get the marks from the computer needs to know the roll number. Okay, computer needs to know the roll number. So it cannot give the marks unless it knows the, to get the marks, the computer should know the roll number. Only the roll number is being feeded into the computer. So if you know the roll number, you'll get the marks. But Amit doesn't know the roll number. So what he can do, he can go for one more option, that is register. So your attendance register. So attendance register will have your roll number. So if Amit goes and checks in his register, he'll get his roll number. Correct. If he goes and checks in his register, he'll get the roll number. So if he gets the roll number, if he put it into the computer, so he'll get the mark. So you can see that Amit, okay, Amit, in order to get the marks, first you have to check the register, and then from register he'll get the roll number, because the computer has only the roll numbers, it doesn't have the name of the student. Okay, so when he knows the roll number, he'll get the marks. Here you can see that in order to get the marks directly, he has to go into several steps. So what is that step? First he has to check the register. That is the first step. What else he has to do? He has to go and put that roll number in the computer so that he can get the marks. So this is a second function. So you can see that the first function is register and second function is checking that roll number in the computer. So you can see here, after two steps only he'll get the required thing, that is the marks. So this is nothing but composition of functions. So in order to simplify, or what is the definition in a mathematical way, suppose you have two functions, f from a to b and g from b to c. Okay, suppose you have f from a to b and g from b to c. Both are functions. So what thing you can see, whether there is something which is which you can pop up, which is popping up into your eyes. So you can see that. What is the domain of function f? It is a. What is the codomain? B. What is the domain of g? It is b. What is the codomain? C. So you can see that the domain of the g and codomain of f, right? This is codomain, this is domain. So domain of b and codomain of f are same. So what is that? You'll have three sets. Okay, you'll have three sets, A, B and C. Okay, you'll have three sets, A, B and C. So what is this mapping? This mapping is nothing but f from A to B, correct? F is going from A to B. So if I have x over here, after applying the function, what answer I'll get? The answer is nothing but f of x, correct? The answer which I get is f of x. So the function which maps B and C is g. Okay, the function that maps B and C is G. So for G, the elements, the domain is nothing but set B. B contains those elements in the form f of x. Correct. So if you want, see, if it was x, after the function f is applied, it becomes f of x. So when the function g is applied on this particular element, now f of x is an element. F of x is an element in our domain. So if you apply g to this f of x, what will we get? It will get g of f of x. There is nothing as complicated. If it is x, once we apply f, it becomes f of x. Now f of x, you take it as some element. F of x, you take it as y. Okay, f of x, you take it as y. Now you have to find, you'll apply g for this y. Then what happens? What we'll get here? We'll get g of y. But what is y? Y, I have taken it, f of x has been taken as y. So it becomes g of y. So this, in turn, this is called as composition of functions, and we represent it by g composition f, and it is mapped from, where is it mapped? It is mapped from A to C. Okay, so this is nothing but composition of function. So composition of function, g composition f, is defined as the function g composition f from A to C, and it is given by g of f of x, because the domain is A and A contains the elements of the form x. So g of f of x is nothing but g of f of x. So first you have to find what is f of x. From x, find what is f of x, apply it to the function g, so that you'll get the g of f of x. So the direct part is called as g composition f. So the second function should be written first, and first function should be written second. This will be happening only if the domain of one function is equivalent to the codomain of the other function. Only in such case we can go for composition of functions. I hope you have got a slight idea about what you mean by composition of functions. In the next class, we'll discuss about an example, so that makes you very clear what the definition actually means. Thank you.